Welcome. Today we're diving into VMware vSphere's Distributed Resource Scheduler, or DRS. If you've ever wondered how your virtual machines get the resources they need, or how your cluster stays balanced, this is the place to start. DRS is a powerful solution that manages resource allocation and load balancing across a cluster of ESXi hosts. It ensures your VMs are running efficiently, automatically enforcing resource policies and adapting to changing workloads. In this video, we'll break down how DRS works, the factors that influence its behavior, and walk through real-world scenarios to help you get the most out of your vSphere environment. Let's start by understanding the core purpose of DRS and why it's so essential for modern data centers. At its core, DRS is all about keeping your virtual machines happy by ensuring they always have the compute resources they need. It does this by monitoring the cluster's balance every 5 minutes and taking action if it detects any imbalance. DRS automatically decides which VMs would benefit from moving to another host and uses vMotion to migrate them seamlessly. This process helps maintain optimal performance for all applications running in your environment. Whether it's a new VM powering on or a workload spike, DRS is constantly working in the background to keep things running smoothly. Let's look closer at how DRS achieves effective VM placement and efficient load balancing. When a virtual machine is powered on in a DRS cluster, DRS runs its algorithm to determine the best ESXi host for it. This initial placement is crucial. It ensures the VM gets all the resources it needs right from the start without violating any constraints. DRS considers the VM's demand, which includes the resources it needs to run efficiently. By placing VMs optimally, DRS reduces the need for frequent load balancing later. However, workloads can change over time, so even with the best placement, some rebalancing may be required. Next, we'll see how DRS handles ongoing load balancing to maintain cluster health. A well-balanced cluster means resources are evenly utilized across all hosts. DRS uses a balance metric, calculated from the standard deviation of resource utilization, to make load balancing decisions. Every 5 minutes, DRS checks for imbalances and if needed uses vMotion to migrate VMs between hosts. This keeps workloads distributed and prevents any single host from becoming a bottleneck. By continuously monitoring and adjusting, DRS ensures your environment remains responsive and efficient, even as workloads shift throughout the day. DRS calculates the resource demand for every running VM in the cluster. For CPU, it looks at the amount currently being consumed. For memory, DRS uses a formula that factors in active memory, swapped, shared, and a cushion of 25% of idle consumed memory. This approach ensures that VMs have enough resources for their current workload, plus a buffer for sudden increases. By focusing on active memory, DRS can efficiently manage memory workloads even in overcommitted environments. Understanding how DRS calculates demand is key to optimizing your cluster's performance. DRS doesn't just look at current usage, it also tracks trends and availability data for each VM and host. Metrics like CPU average, CPU max, CPU ready time, and memory swapped help DRS identify resource shortages and usage spikes. By correlating these data points, DRS can predict when a VM might need more resources and proactively rebalance the cluster. This predictive approach helps prevent performance issues before they impact your applications, keeping your environment running smoothly. Every vMotion migration comes with a cost, mainly in terms of CPU and memory usage on both the source and destination hosts. DRS weighs this cost against the benefit, improved performance for the migrated VM, the source host, and overall cluster balance. For large VMs, the migration cost can be significant, so DRS carefully evaluates whether the move is worthwhile. Additionally, DRS considers workload patterns, avoiding unnecessary migrations for VMs with spiky usage. This smart analysis ensures that migrations only happen when they truly benefit the environment. DRS offers several customization options to fit different cluster needs. Factors like automation level, aggression level, VM overrides, and rules can all influence how DRS operates. By understanding and tuning these settings, you can optimize DRS for your specific workloads and business requirements. In the next scenes, we'll explore each of these factors in detail, starting with DRS automation levels. DRS can operate in 3 automation modes: fully automated, partially automated, and manual. In fully automated mode, DRS handles both initial placement and load balancing automatically. Partially automated mode automates only the initial placement, leaving load balancing recommendations for you to apply. In manual mode, you must approve all recommendations. You can set the automation level in the cluster settings, giving you control over how much DRS manages on its own. Choosing the right level depends on your operational preferences and trust in DRS's decisions. The DRS aggression level, also known as the migration threshold, determines how much imbalance is tolerated in the cluster. There are 5 levels, from 1 most conservative to 5 most aggressive. Higher aggression means DRS will migrate VMs more frequently to achieve a more even load distribution. The default is level 3, which works well for most environments. Adjusting this setting lets you balance between minimizing migrations and maximizing resource balance, depending on your priorities. Sometimes, you need DRS to treat certain VMs differently from the rest of the cluster. VM overrides let you set specific automation or migration thresholds for individual VMs, or even exclude them from DRS recommendations. This is useful for critical workloads or special cases where you want more control. You can configure VM overrides in the cluster settings, ensuring that DRS respects your unique requirements for each VM. VM host rules give you granular control over VM placement. You can create rules to keep certain VMs together, separate them, or ensure they run on specific hosts. These rules are especially useful for performance, licensing, or compliance reasons. DRS must honor these rules when making placement and migration decisions, though some rules can be relaxed if cluster imbalance becomes severe. Understanding and using VM host rules allows you to fine-tune your environment for both flexibility and control. There are several types of VM host rules. VM affinity keep VMs together, VM affinity keep VMs apart, and VM host rules assign VMs to specific hosts or groups. Each rule can be set as must, mandatory, or should, preferred. Mandatory rules are always enforced, while preferred rules can be relaxed if necessary to maintain cluster health. These options give you the flexibility to meet business or technical requirements without sacrificing performance. To implement VM host rules, you first create VM and host groups in the cluster settings. These groups allow you to define collections of VMs or hosts for use in rules. Once groups are set up, you can create rules that specify how these groups interact, such as keeping certain VMs on certain hosts or ensuring separation. This structured approach makes it easy to manage complex environments with many VMs and hosts. DRS leverages 3 key resource management tools: reservations, limits, and shares. Reservations guarantee a minimum amount of CPU or memory for a VM or resource pool. Limits cap the maximum resources a VM can use, preventing it from consuming more than its share. Shares determine priority during resource contention, allowing you to favor critical workloads. Together, these tools give you fine-grained control over how resources are allocated in your cluster. A reservation ensures that a VM or resource pool always has access to a specified amount of CPU or memory. This is especially important for critical workloads that cannot tolerate resource shortages. Reservations can be set at the VM or resource pool level, guaranteeing that essential applications remain responsive even during periods of high demand. A limit sets the maximum amount of CPU or memory that a VM can consume. This prevents non-critical VMs from using excessive resources and potentially starving other workloads. Limits are useful when you want to contain resource usage for specific VMs, especially in shared environments. Shares determine the relative priority of VMs or resource pools when resources are scarce. By assigning more shares to critical VMs, you ensure they receive a larger portion of available resources during contention. Shares only come into play when there isn't enough to go around, making them a flexible way to prioritize workloads without overprovisioning. While DRS works well with default settings, advanced options let you fine-tune its behavior for special cases. These options are specified as key-value pairs and can adjust how DRS calculates demand or balances resources. For example, you can change how much idle memory is considered during load balancing. Advanced settings are powerful tools for experienced administrators looking to optimize performance in unique environments. Monitoring DRS is essential for understanding cluster health and diagnosing issues. The Summary tab shows the current balance state, DRS settings, and any faults. The green bubble level indicates whether the cluster is balanced. If the bubble is off-center, there may be an imbalance that needs attention. By regularly checking these indicators, you can ensure your cluster remains healthy and responsive. The DRS Monitoring tab provides deeper insights into DRS behavior. Here, you can view recommendations, history, faults, and utilization statistics for CPU and memory. These views help you troubleshoot issues, understand DRS decisions, and optimize your cluster's performance. Keeping an eye on these metrics ensures you can quickly respond to any emerging problems. In partially automated or manual mode, the recommendations view lists all DRS suggestions that require your approval. This includes both initial placement and load balancing moves. Reviewing these recommendations helps you understand DRS's logic and ensures that critical actions aren't missed, especially when overrides or special rules are in place. The history view shows all actions taken by DRS, including vMotion migrations and initial placements. This audit trail helps you track changes over time, identify patterns, and troubleshoot unexpected behavior. By reviewing the history, you can gain confidence in DRS's decisions and spot any recurring issues. The Faults tab lists any issues DRS encounters, such as rules it can't satisfy or migrations it can't complete. While not all faults are critical, monitoring this section helps you identify and resolve problems before they impact performance. Regularly checking for faults is a best practice for maintaining a healthy cluster. The CPU Utilization Summary provides a visual overview of CPU usage across all hosts in the cluster. You can see how much CPU each host is consuming and drill down to VM-level details. This helps you spot imbalances and identify which VMs or hosts may need attention. The Memory Utilization Summary shows how memory is consumed across hosts. While DRS balances based on active memory, this view helps you understand overall memory distribution. By hovering over the bars, you can see VM-level memory usage, making it easier to diagnose issues and optimize resource allocation. Let's look at a real-world example. In a cluster with 3 hosts, powering on several CPU-heavy VMs without DRS results in all VMs landing on the same host, causing resource contention and CPU-ready time. When DRS is enabled, it calculates each VM's resource demand and places them across different hosts, eliminating contention and improving performance. This demonstrates how DRS's initial placement algorithm proactively prevents bottlenecks. In another scenario, DRS balances memory based on active usage. If one host has low active memory but high consumed memory, DRS may migrate VMs to balance active memory, potentially causing swapping if the host is already full. By adjusting the advanced option to consider all consumed memory, DRS can avoid unnecessary migrations and prevent performance issues. This highlights the importance of tuning DRS for your specific workload patterns. When VM overrides and affinity rules are in place, DRS may generate recommendations that require manual approval. If these recommendations aren't applied, DRS can't proceed with further balancing, leading to persistent imbalances. This case study shows the importance of monitoring and acting on DRS recommendations, especially when custom rules are involved. Critical VMs may require guaranteed resources at all times. Without reservations, these VMs can experience ballooning or swapping during periods of contention. By setting reservations, you ensure that essential workloads always have the resources they need, even in overcommitted clusters. This is a best practice for high-priority applications. Shares are a powerful way to prioritize resources during contention. In this example, 2 VMs compete for memory within a resource pool. By increasing the shares for the critical VM, it receives more resources during contention, preventing ballooning and swapping. Shares only matter when resources are scarce, making them a flexible tool for dynamic environments. The migration threshold setting directly affects how aggressively DRS balances the cluster. At the default level, DRS may tolerate some imbalance to minimize migrations. Raising the threshold makes DRS more aggressive, resulting in more migrations and a more even distribution of resources. This trade-off lets you choose between fewer migrations and tighter balance, depending on your operational goals. DRS can automatically make prerequisite moves to satisfy affinity or anti-affinity rules before placing a new VM. For example, if a powered-off VM is part of several anti-affinity rules, DRS may move other VMs first to ensure the new VM can be placed without violating any rules. This intelligent behavior minimizes manual intervention and keeps your environment compliant with your policies. In summary, DRS is a sophisticated tool that keeps your virtual environment balanced and responsive. By understanding its core mechanisms, customization options, and real-world behaviors, you can harness its full potential. Whether you're optimizing for performance, compliance, or operational simplicity, DRS provides the flexibility and intelligence needed for modern data centers. To get the most from DRS, regularly monitor your cluster's health, review recommendations, and adjust settings as your environment evolves. Use reservations for critical workloads, set appropriate shares for prioritization, and leverage advanced options for special cases. Stay proactive with monitoring and troubleshooting to ensure your cluster remains balanced and your applications perform at their best. For further learning, VMware provides extensive documentation, best practice guides, and community forums. These resources can help you deepen your understanding of DRS and stay up to date with the latest features and recommendations. Leveraging these materials ensures you're always making informed decisions for your environment. This guide was created by experienced engineers and leaders from VMware's vCenter Server Performance Group. Their expertise in resource management and scalability ensures that the information presented is both practical and reliable. Learning from industry experts helps you apply proven strategies in your own environment. Special thanks to the contributors and reviewers who provided valuable insights and feedback for this guide. Collaboration among experts ensures that the recommendations and explanations are comprehensive and actionable for real-world scenarios. VMware's commitment to innovation is evident in the ongoing development of DRS and related technologies. By staying current with VMware's latest releases and best practices, you can ensure your virtual infrastructure remains robust, flexible, and future-proof. For more detailed information, consult VMware's official documentation, white papers, and technical guides. These references provide in-depth explanations, configuration examples, and advanced troubleshooting tips to help you master DRS in any environment. As data centers evolve, DRS continues to play a vital role in ensuring efficient resource utilization and high application performance. Its adaptability and intelligence make it an indispensable tool for administrators managing dynamic, large-scale environments. VMware is continually enhancing DRS with new features and smarter algorithms. Staying informed about these advancements will help you take advantage of improved automation, better performance, and greater flexibility in your virtual infrastructure. To recap, DRS automates resource allocation, balances workloads, and adapts to changing demands in real time. By leveraging its features, automation levels, aggression settings, overrides, rules, reservations, limits, and shares, you can tailor DRS to your unique environment. Regular monitoring and tuning ensure your cluster remains healthy and efficient. Thank you for joining us on this journey through VMware DRS. With the knowledge and best practices shared here, you're well equipped to optimize your vSphere clusters for performance, reliability, and scalability. Continue exploring, stay curious, and make the most of your virtual infrastructure. For ongoing updates, tips, and community support, connect with VMware's online resources and forums. Sharing experiences and solutions with peers helps everyone get the most out of DRS and vSphere. Thanks for watching, and see you next time.